All right. Now it's an honor to present our next speaker, Peter Robejsek, Managing Director for MasterCard in Germany. A long-term expert on machine learning and its impact on business, he's been a key driver of MasterCard's digital banking and payment systems. And to be honest, I can't think of anyone better to give us a perspective on business, the way business approaches AI, and the responsibility that comes with it. Now, Peter, thank you so much for coming.
Hi, everybody. So we have again technology taking place. Let's see that we make this work, and then we'll get started. Let me see. Where's the camera? Where should I be looking? Over there. Okay, cool. Got it. All right. Okay, so you should be able to see some slides now. Yeah, that looks promising. Good. So, hi, I'm Peter. Very pleased to be here. Many thanks for the opportunity. I'll be talking a little bit about AI and trust in payments. To do that, I need to explain to you a little bit about who we are and what we do as MasterCard. You may have heard of us. We're a medium-sized fintech that ensures that 3 billion people on the planet can pay at 100 million outlets. But we are a little bit long in the tooth. Let's go back in history and look at the year of 1969. Some rather important historical events took place during that year. We had the Apollo mission to the moon. The Russians had made it before in 1959, of course, and then everybody was panicking and finally put a manned mission on the moon in 1969. A lot of optimism came out of that, which unfortunately hasn't really materialized, if you ask me. Regarding space research. We had Richard Nixon. I think not a lot of his legacy is left after the Trump administration basically dismantled the Environmental Protection Agency, which might just be the one good thing which Nixon put in place. I think there isn't a lot of his legacy left. We had obviously the sort of antithesis of Nixon, which is the Woodstock movement and the philosophy behind that. I think they didn't get along very well, and regrettably, recent events in Ukraine show us that the vision of a peaceful world hasn't really materialized as expected. And finally, supersonic consumer travel across the Atlantic on the Concorde started in 1969, and it really also hasn't taken off. In 2003, the program was stopped due to a lack of viability and security concerns. But one other thing happened in 1969, and that is that this thing came into existence. It might look familiar. The circles certainly should look familiar to you. This is what pretty much now 3 billion people have in their wallets worldwide. Of course, some changes, some technological developments have taken place, but it's really virtually the same thing. But the question is really, what is this really that I'm showing here on the screen? Basically, this is a set of rails. This is a means of transmitting information, information that is unalterable, that is reliable, that is secure. And this is what payment basically is. But since 1969, competition has really taken off and become quite fierce, to be honest. So nowadays, there are lots of different sets of rails that are competing for the attention of business and consumers, and that's absolutely fair and that's fine. But especially with the advent of AI and in particular generative AI, I think it's come to the fore once again that the essential ingredient of this competition in payments is trust. Being a reliable payment network, being a payment provider is all about trust that is put into you by the consumers and by the businesses. And that's what we certainly aspire to and what we stand for. And this is also what sort of underpins our motivation to work on applications of AI in payments. And let me share with you two specific sort of areas in which we're working on these applications. One of them is identity. So identity theft is an issue. The 13.7% that you see here on the screen, that's the CAGR of the identity theft protection services market. So clearly there's a high demand to protect oneself against this threat, which is becoming ever easier to execute nowadays. 60% of consumers would immediately switch their provider, their financial service provider, if they found themselves exposed to identity theft. And 71% of them believe that identity theft is the biggest concern that they have nowadays. And finally, BaFin has found that fake job applications are a real thing, and faking something nowadays has become much easier than before with the use of AI. So what to do against that? What are we doing against that as a payment network? We don't need to do everything ourselves. We can also invest into technology that is already there and that works. Two investments that MasterCard has recently made are NuData and Icata. And they tackle different aspects of the value chain. I think it's clear that in payments, it's always a delicate balance. It's about sort of maximizing user experience and making it as frictionless as possible. At the same time, you want to avoid fraud and prevent fraudulent behavior on the network. So, how do you balance that? And here, analytical AI clearly comes into its own. So, with the sort of approaches from NuData, we identify the authenticity of a device and also the behavior of a user matched to that device. That happens in the background without any explicit interaction with the consumer, and it can give a financial service provider information about, is this an authentic person, and is this the person that they claim to be who is interacting with the point of sale and the payment network. Icata, on the other hand, is sort of aiming at the front end of the value chain, so aiming to avoid or make it as smooth as possible to enter a customer journey in payments. And it does so by using a very frugal set of data. 5 data points are sufficient in order for this algorithm to verify that these 5 data points in their coexistence, as they are being presented to any front end, let's say a merchant or a bank, that they are in their totality plausible. So I can go online and generate a fake ID in seconds nowadays. This is not an issue. And these fake IDs will typically use real data, but that data is pieced together in an implausible way. So we use AI to detect the plausibility of these data sets that represent fake consumers. And by doing so, we can avoid fraudsters coming into the value chain in the very first place. Second example I want to talk about is this. This is sort of a high-level view, and I hope you can all see all of the details. No, just kidding, you're not meant to see that, but just get an idea of what it is. It's the real-time payments network in the UK, which is being operated by Vocalink, a MasterCard subsidiary. And that's sort of one view of it. Financial crime is obviously massive, especially in a real-time payment setting when an irrevocable payment can be made instantaneously. The transport and the ferrying of illicitly gotten funds from one account to the other is something that is a real thing. Nowadays, financial crime represents about $2 trillion US, depending on the year, 2 to 5% of global GDP. And so we really need to do something about it, because once the money's gone, it's gone, and the bank that owns the account of the person who was defrauded, they can hardly do anything about it. They usually will have to come up with sort of compensation for out of their own goodwill, but there isn't really a lot that they can do to recover the funds. With the help of AI, they can. So let's zoom in a little bit and let's look at this sort of network in a slight bit more detail. So the orange dot that you can see here, that's sort of the account of the person who was defrauded. And the little sort of yellow movement that is happening on the screen represents the flow of funds to some other accounts represented in white. Those are so-called mule accounts, so accounts that are either owned by the fraudster or unknowingly are legitimate accounts which have been unknowingly taken over by fraudsters. And what you can see here is that in order to mask the origin of these illicitly gotten funds, the money is being transferred from account to account until it finally vanishes somewhere, some crypto exchange, or is simply withdrawn. If we look at it in a slightly different way, it looks like this. So you have an initial sort of fraudulent transaction. A lot of money goes into one account, and then the little bars show you that it's being sliced and diced across a multitude of other accounts. Some of the transactions are very, very small. Those are happening on screen right now, and this is sort of a testing transaction. So the fraudster wants to know, is this account still one account that I can use in order to sort of carry out future transactions, or has it perhaps been shut down in the interim by the financial services institution? So what's happening here is really hard to prevent in real time, but we can. So with our sort of AI applications, what happens is this. All of the bars that you now see in green are such that they can be prevented from ever occurring in the first place, because we have a very high prediction rate of which account is likely to be a fraudulent account or one that is implicated in the masking and in the movement of these illicit funds. So that is sort of an algorithm fairly large in size, based on 20 billion transactions. 700 million is sort of the size of the labeled data that we use to train that algorithm, and we achieve a 90% detection rate. Virtually every significant UK financial services institution is using that on the faster payment system in the UK. So these are two applications of analytical AI in payments, helping us to sort of make payments more frictionless, more secure, and prevent fraud. But of course, the big thing that everybody's discussing today is generative AI. This is a completely new class of thing. And here also some important sort of observations need to be made. When I started my PhD on artificial neural networks, I was operating a fairly modest data set, 100,000 observations, 200 variables, a couple of 100 parameters. Compare that to what is state of the art today, it's tiny, right? I mean, GPT-3, 8 million documents, billions of words. GPT-4 cost $100 million to train. So, thanks to the evolution and computing power that we have seen, these huge models have become possible. But only very recently, we are having the debate now about, should generative AI models actually continue to grow, or is it possible now to sort of decouple the growth of this a class of technology from the size of the data corpus and the computing power that you have at your disposal? And it turns out that, yes, it is. It's becoming much more democratized, the access to generative AI technology. And I think there's one very important implication in this. And it's also illustrated by the chart here, which shows that about 1/3 of all AI startups in Europe are working on generation of text, which is virtually indistinguishable as to its veracity. The important message for financial services and payments from generative AI, in my opinion, is that it's a massive boost to companies which stand with their balance sheet and with their operations for the veracity of the information that they transport. This goes for banks, this goes for payment networks, because faking things has become so easy with the use of generative AI. Having institutions that are trusted and reliably trusted because they have skin in the game has become an absolute differentiating factor. So everything comes back again to that feature of trust that we need to earn and keep from our stakeholders. And with that, I want to close and take any questions that might have arisen.
Thank you very much, Peter. Please, any questions from the audience, any questions of the chat, feel free to shoot now. Yes?
You mentioned biometric features you would like to use in order to make it safer, better than a 3-digit number. So what are the biometric features you're thinking of? Classical fingerprint, movement models, what do you have in mind?
So it's basically the sky is the limit, right? I think that the sort of typical technology that is already there today are things like facial recognition and fingerprint sensing and all of that, and that will only continue to improve in accuracy. But especially if you think about sort of emerging use cases like in-car payments, you can start to think of sort of using the behavioral patterns that are being reported back by the machinery of the car So how intensively is this person accelerating? How intensively, or how are they steering? What is their behavior? All of this data is available. That is, in a sense, a biometric data point because it uniquely identifies the person. That, as far as I'm aware, is not yet being used as an authentication method, but it could be, provided it's sort of proven to work and regulators are convinced.
So you would introduce your technology in a more complex system, like a camera observation system in a car, whatever, in order to make it safer. So not just your terminal is safe, but it is part of a safe environment, right?
Well, that too, that's another aspect that's sort of beyond biometrics, where you're talking about the fact that the machine which is executing a transaction, that could be a smartphone or that could be a car, is in and of itself a secure environment. So then you have a hardware technology there, which is sort of taking care of that. Yeah, it's another aspect.
Thanks.
Thank you very much. Thank you for your questions. Thank you, Peter, for being so forthcoming with your answers.